have started to flow about all the what ifs, the hey can you print, the hey what if I didn't, the this, that's, and the next things. And so guys, you'll notice that I ignored most of your questions because I wanted to answer them corporately. So guys, this is the fundamental understanding. We've known about this assignment for 2.5 weeks. You knew that it was due this morning, and you knew that you were turning in a printed copy of your paper. And so guys, with that as the baseline understanding, let me explain to you where that then puts us. So guys, remember, I'm not grading these papers. These actually go to the same graders that grade all of the English work that you submit. But guys, what I learned yesterday is that your papers will be picked up next Thursday morning, so 6 days from now. So guys, what that means is that we have sort of a little bit of wiggle. So understand, if you didn't turn in your paper now, it's late. But with that said, I can still take your papers from you and get them graded if you get them to me by Wednesday at the end of the day. Anytime in there is fine. But guys, these people come and pick up these papers at 7 a.m. They're college students that are struggling to find time in their days. So guys, they come by Thursday morning at 7 a.m. So what's going to happen is Wednesday evening, I'm going to take these to Ellingford, and he will then hand them to the graders. So guys, if I don't have your paper by Wednesday, understand that it will not get sent off to grading. What that means is you can still turn it in. So if you don't turn it in by Wednesday, you can still submit it. But it will not get graded until we send in the rewrites. We're going to pass these by the graders twice. Everybody's paper, if you've turned them in, will go in Thursday and we'll get those back. And then guys, remember, you do have the opportunity to rewrite these papers. And so we'll talk about the rewriting process after we get them back. We already talked about it a little bit. And then we'll submit that rewritten batch of papers, I don't know, sometime in December. But all of that to say, guys, if you don't get your paper to me by Wednesday, it will miss the initial grading. It will then get submitted with all the rewritten papers, and you will not then have the opportunity to rewrite it. So again, guys, if you didn't turn in your paper now, it's late. I need it before Wednesday. And then if you miss that deadline, it just means you missed the chance to rewrite. So guys, with that said, I'm actually excited. This buys me 6 days to read over your papers prior to them actually being formally graded. And I'm looking forward to reading through these, guys. I've had enough conversations with some of you about how this has been an interesting and challenging thing, and I look forward to seeing what you wrote. So guys, questions about the calendar, questions about your papers? You guys okay? Okay, so let's do this really quickly then. Guys, today what we're going to do, we're not going to look at the little bit of homework number 2 that we started. What we're going to do in just a minute is pick up where we left off and continue into this idea of all of these structures. Guys, if you've started the extra credit, you're going to find that what we're about to do is only going to reinforce what you're thinking about. And then guys, we're going to come back on Tuesday, last of the new material, and then Thursday will be the test over this unit. Now guys, full disclosure, the football game yesterday threw off our A-B schedule, and so we were actually originally looking at doing an activity on Monday, but then Miss Call's class can't, and my A-Day class can't do the activity because it pushed their test back to the day before Thanksgiving. So what we're going to do is on Monday, guys, we're going to watch a NOVA video over what it might look like if our world that we live in obeyed the same rules as the subatomic world, where things are waves and particles at the same time, things come in and out of existence. So guys, the bottom line is on Monday, we're doing something that you don't need to make up. You're going to love it. It's a really interesting video. But guys, we're going to do that on Monday. So if you know that you're leaving early for Thanksgiving, you'll have nothing to make up. And then we'll do this activity when we get back after Thanksgiving. So what about now? Calendar questions? Y'all okay? Okay, so guys, do this. Grab the notes that you started last time. If you don't remember, they look comprising, oh, they already recycled my papers. Do you guys know what I'm talking about? The thing with the rungs on the ladder in the 1s2, that. And then, guys, you need your periodic tables, and obviously you need something to write with, and we're going to get started. So, guys, again, periodic tables, note-taking materials, or just your notes from last time, and we are going to start right here. All right, you guys good? Okay, so guys, let's reconnect this way. When I saw you last Wednesday, on Wednesday, guys, we left off, we stopped at talking about the extra credit project. And guys, if you look down at your class notes, you realize that we built up this idea of the rungs of the ladder, 1S, 2S, 2P, 3S, 3P, 4S, 3D, 4P, and so on. And then, guys, we said your extra credit assignment is to turn this into this. So, guys, nope, not that. Hold on just a second. Guys, what you were trying to do is take this model where you've got these boxes that represent orbitals and respect the idea that this is a small sphere and a bigger sphere and dumbbells and sphere and dumbbells and on up, and turn that into this model. So guys, that is the extra credit assignment, is to turn all of the boxes on the previous slide and in your notes into 2 or 3 dimensional models. Now guys, I don't know if we talked about this directly in last time, so let's be clear. Guys, these things have got to be correct by shape, size, and number. Did we talk about that? Maybe? Not sure. Let's talk. So guys, they have got to be correct by shape and size and number. And guys, what that means is that this assignment did not receive full credit. This is not good. So let's talk about why. So guys, what is this little sphere right here? That's the 1s orbital. What's this sphere right here? The 2s. Now, is that okay? Well, let's look. The 2s is bigger than the 1s. That's good. And it's a sphere. That's good. And it does get bigger from the 1s to the 2s. And there's one of each, so this is good. So guys, what does that make this? The 2P, and this is bad. Guys, why is this guy bad besides the fact that one of the lobes fell off? Guys, why is this bad? It's too big. It should be the same size as the 2S. So guys, this lost points because these should be about the same size. Technically, the P is a little bigger than the S, but these should be about the same size. So now let's go to the 3S. This is also bad. Why is this guy bad? Because it should be bigger than this, right? These get bigger as we go 1 to 2 to 3, but then within the 1 and the 2 and the 3, they should be the same size. So guys, with that said, looking over on the right, your left, guys, what's an example then of a project that received full credit? Well, let's take a look. What about this one? Is that one good? Yeah, and I agree. Let's take a look. Let me grab, where's my laser? Where'd my laser go? Oh, here it is. So guys, let's take a look. So we've got the 1S, the 2S is bigger, the 2S and the 2P are about the same size. Then we've got the 3S that is bigger than 2, the 3S and the 3P about the same size. Then the 4S is bigger than the 3rd, and then this must be the 3D, which is about the same size. I'd say that's pretty spot on. But guys, those are the things that we're looking for: shape, size, and number. Again, if you want full credit for this, it needs to be original. Understand that you're not going to lose a lot of credit if you sort of mock one of these, if you take one of these ideas. But guys, for full credit, it not only has to be correct, but it has to be original. That's actually where that terrifying fan project came from, which we plugged in and it almost caught on fire. So, guys, now questions on the extra credit now that we've had a chance to talk about it again. When are they due? Thursday, the day of the test. So guys, these are due on Thursday. Feel free to work with a partner. You don't share the points. You get full points for each of you. And I would encourage you to work with a partner, but that's totally up to you. So guys, questions about the extra credit? You guys good? Okay. So guys, let's jump in then and let's talk about where we are, and then we can talk about where we're going. So guys, this is what you should understand right now. Please ask questions if you need. So here's what we know. We know that energy levels are broken into sub-levels. And guys, those sub-levels are S and P and D and F. Then those sub-levels are broken into orbitals, and the orbitals are actually the clouds that the electrons are paired up in. Then guys, we understand that none of these orbitals are shaped like boxes. This is a small sphere, this is a bigger sphere, these are dumbbells of about the same size, this is an even bigger sphere, bigger dumbbells about the same size, bigger sphere, you get the idea, and then the clover leaves and the Fs, which are kind of beautiful actually. But we've got energy levels broken into sublevels, broken into orbitals that contain electrons. How you guys doing? Things there you want to talk about? Okay. So guys, this then is what we're going to do today. This is actually not going to take long at all, and you're gonna get your homework done today. You'll walk out of here without homework. So guys, here's what we're going to do today. You may remember from the Hank Green video, and I actually paused it, and he was showing that diagram with the arrows that went across it. Do you remember that? And I said, hey guys, this is the way that I learned this in high school, but you won't have to memorize it because you're going to understand it. Guys, that's what we're going to talk about right now. Because the intent of that diagram was actually to teach you this pattern. Because you need to know the 1s, then the 2s, then the 2p, then the 3s, then the 3p, then the 4s, and then the 3d, and then the 4p, and on up from the bottom. So guys, you need to know this pattern. Now again, Hank and I in college learned it with arrows. But guys, you don't have to memorize the arrows. Here's why. Guys, when you walked in here this morning, and I know that we looked at this last time in class, but guys, when you walked in here this morning, every single one of you already have in your possession the chart that goes 1s, 2s, 2p, 3s, 3p. That chart that Hank said he had to memorize. Guys, every single one of you already have that chart in your possession. Where is it? It's the periodic table, you guys. That's the order that the periodic table is put together. This idea of 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d. Guys, that is the structure of the periodic table. So what we're going to do is, and you want something to write with, probably, well, pen or pencil, doesn't matter. Guys, we are going to take our periodic tables and we are going to structure them. We're going to write this into our periodic tables. And when we do, you will never have to memorize this information. So guys, many of you have your periodic tables tucked into like a clear plastic thing or the front of your binders. Guys, get them out because we're going to label these things. So guys, check this out. Where on the periodic table is all this information? Well guys, first of all this, looking at your class notes, guys, you understand that this doesn't just go 1, 2, 3, 4. How far does it go? Up to 7. But guys, check this out. 1 through 7 on your periodic table are actually the horizontal rows on the periodic table. 1, 2, 3, 4, 5, 6, 7. Guys, the horizontal rows on the periodic table represent the energy levels, so let's label them 1, 2, 3, 4, 5, 6, and 7. Now guys, this. Energy levels are broken into, you guys good on the 7? So guys, energy levels are broken into sub-levels. Those sub-levels are S and P and D and F. Now guys, you should be able to answer this question. How many electrons are in each S sub-level? 2. We've got 2 here, 2 here, 2 here, 2 here. So guys, we need to find a region on the periodic table that is related to the number 2, and I suspect you all see it. Guys, these 2 columns on the periodic table represent the S sublevel. So guys, up here above, please write S above the 2 far left-hand columns on the periodic table. But now, guys, in order for this to work, you also need to then do this. Guys, move helium over. Do not erase it or cross it out on the right. But guys, technically, based upon electron structure, helium should be there on the periodic table. In order for you to understand why it isn't, there's some chemistry you need to know. We'll talk soon. But guys, understand that helium actually technically belongs in both places at once. So all you got to do is draw a little box there and then just call it helium and put the number 2 in there just so you have the mass and you'll be good to go. Or the atomic number. You guys good? So we've got 1 through 7, we've got S. So now, guys, what we need to do is we need to find the P's. And you know that there are 6, 6, 6. There are 6 electrons in the P sublevel. So you turn your attention back to the periodic table. And where's a region on the periodic table that has something to do with 6? Far right-hand side. Guys, it's these dudes right here. 1, 2, 3, 4, 5, 6. This region right here represents the P sublevel on the periodic table. Now, guys, let's continue from there. Now we need to find the SPD sublevel. And guys, coming back over here, the D sublevel always has 10 electrons. So guys, where is a region on the periodic table that has something to do with 10? The saddle. Guys, the saddle on the periodic table is the D sublevel. But when you write down D, please in parentheses, write down -1. They do. So all of these are in the S. All of these are in the P. Oh, shoot. All of those are in the P. All of these are in the D. And then I almost gave, well, it's not even giving anything away, right? Guys, weird, but not coincidences, weird connections. So guys, let's do the next one. We've got the F's. The F's have 14 electrons. Guys, what's the only place that's left on the periodic table? The super bottom. And you probably don't even need to count because you can trust that this entire region is 14 boxes wide. Feel free to count if you want. But guys, that is the F sublevel. But we're going to write F -2. Now again, guys, I didn't learn this until my junior year in college. When I was in high school and college, my professors and teachers taught this to me with the arrow diagram that Hank was talking about. But guys, here's the deal. You will always have your periodic tables available to you, and if you've got this information on your periodic table, you can figure out the order of orbital filling, and you don't have to memorize the arrow diagram. So guys, the question then becomes this. Where on the periodic table then is the order that follows along and goes 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, and so on? And guys, the answer is this. If you can count and play the game Battleship, you'll never get these wrong. Do you guys know how Battleship works? You guys ever play Battleship? The idea is that you've got numbers and you've got letters and you can locate any point on a grid with a number and a letter, and you're like A7, and if their ship is there, it's a hit, and if you guys know what I'm talking about. So guys, take that idea and apply it to this. Don't put this in your notes, but watch. So guys, how does Battleship work? And the idea is that we can locate points in space with a number and a letter. So guys, what is that point right there? 3C. You good on that? Guys, what about down here? 4 and B. What about over here? 2 and D. What about there? 2 and B. What about over here? 3A. What about up here? 1C. Guys, what about up here? 1A. What about right here? Come on, y'all. You can, right. You guys, you can do it here, right? What's this point right here? 2B. So guys, what is this right here? 1S. What is this right here? 2S. What is this right here? 2P. Guys, what is this right here? 3S. What is this right here? 3. Come on, guys. If you can do it there, you can do it here. This area right here, 3P. Guys, what's this right here? 4S. Let's do this again. What's this? 1S. What's this? 2S. What's this? 2P. What's this? 3S. What's this? 3P. What's this? 4S. Now be careful. What's this? D, but it's not the 4D. It's -1, so it's 3D. Get it? 4S, and then -1. 4 minus 1 is 3. So what's this? 4. This is 4S. This is 3D, and this is 4P. Let's do it again. What do we got here? 1S in here. 2S. What's this? 2P. What's this? 3S. What's this? 3P. What's this? 4S. What's this? 3D. What's this? 4P. Guys, you just said this. We're going to get there. But guys, look at what you just did. You just said 1S, 2S, 2P, 3S, 3P, 4S, 3D, 4P. Guys, that's the pattern on the periodic table. So now a question. Why is this D minus 1? What does that account for? This overlap, right? We go 3S, 3P, then the 4S, and then we hit the D, but it's not the 4D, it's the 3D, and that's why that's D minus 1, and then we go 4P, so it goes 4S, 3D, 4P, which takes care of this overlap, but then Cole, you're exactly right, this just goes on and on and on. So what if we keep going? Well, this then would be the 5S, and then the 4D, and then the 5P, and now guys, you got to be careful. What's this? 6S, then what's this? 5D, but then guys, look, this goes 57 down to 58. So what do we do? Well, we go -2. So it would be 6 minus 2, which is 4. So it goes 6S, then the 5D, then down to the 4F. Then, guys, it comes back to number 72. And where are we now? Just follow the lines, guys. 6 minus 1, 5D. And then what's this out here? 6P. And guys, you just got to follow the line. So this is 6 and this is P. So then the question becomes, how do we know how to move? And guys, at that point, we just count. So check it out. Electrons 1 and 2, 1S. Electrons 3 and 4, 2S. Electrons 5 through 10 are in the 2P. Then guys, electrons 11 and 12, where are they? 3S. Then what about electrons 13 through 18? 3P, and it just builds from there. So guys, you will always have your periodic tables available to you, and if you can count and play Battleship, you can put these patterns together. So then guys, the question becomes this: what are we going to do with this information? Guys, take your notes page and flip it over on the back. It should be blank. Guys, what are we going to do with this information? And the answer is, we are going to draw what are called orbital filling diagrams. So guys, this is the back of your paper, and you are going to write down in the upper left-hand corner, orbital filling diagrams. Guys, this is the application. You know, in this class, we have the knows and we have the do's. Guys, everything we've talked about up till now are the knows. Guys, this is the do. This is essential. You gotta learn to do this. So guys, let me show you what we're going to do. We're going to draw what are called orbital filling diagrams, and the first one that we're going to do is for the element oxygen. And guys, oxygen is element number 8. So guys, what does the number 8 tell us besides there are 8 protons in the nucleus? There are 8 electrons in orbit. So guys, the question becomes, where are those 8 electrons? Well guys, this is how to figure this out. What we're going to do is we're going to find oxygen on our periodic table. Check it with me. Now guys, which sublevel, let's come back here, which sublevel is oxygen in? We've got 2p. So guys, oxygen is in the 2p sublevel, but we can't put 8 electrons in the 2p sublevel. So where do they go? Well guys, the first 2 electrons go where? 1s. So we're going to come over here and we're going to write 1s. Again guys, you want examples, do this with me. So those first 2 electrons are in the 1s. Now guys, where are electrons 3 and 4? 2s, Battleship, right y'all? Electrons 3 and 4 are in the 2s, so we're going to come over here and we're going to write down 2s. Then guys, electrons 5 and 6 and 7 and 8. Electrons 5 through 8 are in the 2p, so we're going to write down 2p. This is the process. Now guys, after that, the next thing we need are orbitals. So if you need to flip your paper over and look at your notes, feel free to do that. But guys, how many orbitals are in an s sublevel? 2 electrons, but how many orbitals? Well, let's look. We've got 1s, and there's the 2s, and there's the 3s, and there's the 4s. Guys, there's 1s orbital, and it's a sphere. But remember, guys, we don't draw spheres, we draw boxes. So there's 1 orbital in the 1s, and there's 1 orbital in the 2s. Then, guys, how many orbitals are in the p sublevel? Let's count. So there's 1, 2, 3 dumbbell-shaped orbitals oriented 90 degrees to each other. But guys, instead of drawing the dumbbells, we are going to draw 3 boxes. Now guys, what we've got to do is we've got to put our 8 electrons in these 3 boxes. So guys, this is how you do it. Start at the left and work to the right. That's how you want to draw electrons, as half arrows. It goes so much faster. So guys, that's electron 1. How's electron 2 going to be different? Pointing down, because those 2 electrons have opposite spins. So there's electrons 1 and 2. Then guys, here comes electron 3. Where does electron 4 go? Well, next to it, spinning down. So those are our first 4 electrons, but we're building to 8. So now, guys, do this carefully with me. This is electron 5. Now guys, where does electron 6 go? And the answer is surprising. It does not pair up with electron 5. Electron 6 goes in the next orbital over, and then electron 7 goes in the next orbital over. Guys, here's the rule. If you have a sublevel with more than 1 orbital, half fill the orbitals first. So notice in the S's, there was only 1 box. They had to pair up. But in the P, we've got 3 boxes, so we're going to spread them out. So guys, how many electrons are on the board now? 7, but we want 8 for oxygen. If we stop there, we would have 7 electrons, and that would be nitrogen. But we need 1 more electron. That dude is forced to pair up, and this is oxygen. It doesn't actually matter. Yeah, technically you could put them in any of those boxes, but my advice is don't get creative, because if you do, you're going to just make mistakes. Just do the same thing every time, because it always works. So guys, at this point, running through your head is probably one of 2 things, or maybe both. First of all, I'm not exactly sure what we just did. But some of you may also be sitting there going, why the crap do we need to know this? Guys, let me show you. Don't write this down. So, guys, what I'd like to do with you, and I think some of you are going to pick up on this really quickly, but humor me. Guys, now we're going to do the orbital filling. Don't do this. I'll do it. You don't need to. Guys, we're going to do the orbital filling diagram for hydrogen. So, guys, hydrogen is element number 1. Hydrogen is right here in the 1s sublevel. So, we're going to go 1s. And 1 box and 1 electron, and that was hydrogen. But that was so much fun, let's do it again. So we've got 1s, 1 box, 1 arrow, that's another hydrogen. But guys, do you see where this is headed? Guys, check this out. See this empty space right here in oxygen? Guys, that empty space provides an opportunity for hydrogen to come along and stick its electron in that empty space. But oh my gosh, oxygen's got another empty space, and another hydrogen atom comes along and sticks its electron right there, and now we've got 2 hydrogens and 1 oxygen, and what did we just make? That's why water is H2O. See, guys, that's where we're headed with this, is in the next unit, we're going to take these orbital filling diagrams and we're going to lock them together like puzzle pieces, and we're going to start building all sorts of really cool molecules out of these things, because literally, guys, these orbital filling diagrams are just like puzzle, like jigsaw pieces that lock together. Yeah.
But doesn't it get confusing sometimes, like having all the boxes filled like that? So you need like that.
So where is this headed, right? And so the idea is, notice what happens if we take oxygen, and I'm just going to draw them in. If we put hydrogen's electron there and hydrogen's electron there, now this thing is all full up, right? That's actually why atoms bond together. When they bond together, what they're trying to do is they're trying to fill up all the orbitals for the central atom. And so that's actually the point, is that when they do this, they're trying to fill up those orbitals, and that makes them stable and makes the molecules strong. That's exactly where this is headed. Yeah, David? That's a beautiful question. You ready? What would neon look like? Neon is this. Neon is, say it again, I'm sorry. Great, so, but here's the idea. So, oxygen has got 8 electrons, right? Imagine if the black guys weren't there. So oxygen has got 8 electrons, which means it's got 2 spaces left. And so when oxygen bonds to hydrogen, 1 electron goes there, 1 electron goes there. That fills up all of the spaces in oxygen, and now it has the electron structure of neon. Realize it's not neon because it still has 8 protons. So the big idea is this: when oxygen binds with hydrogen to make water, the oxygen takes on the electron structure of neon. It's still oxygen because it's 8 protons, but Zach, and to both of you, that's exactly what's going on, is that when any of these elements react, what they're trying to do is get to the electron structure of these guys, which are called the noble gases, and they're completely full. So we just covered 2 days of material from after Thanksgiving, but that's exactly where this is headed, David. You're barking up the right tree. Guys, other thoughts, other interesting things you'd like to talk about? Okay, we're going to do one more. You should have plenty of room on your paper. But guys, we're going to do one more of these, and then I'm going to kick you out of the nest and let you try these on your own. So guys, let's go to copper. What element is copper? 29. 29 protons in the nucleus, 29 electrons zooming around the outside. Because I'm going to try, I don't know if this is going to work, but I'm going to try. I'm going to write this a little smaller up here. All right, so guys, again, the pattern. Here's the idea. We need to get to copper. Which sublevel is copper in? What's this space right here? 3D. Go ahead. Yeah, good for you. So it's 3D, right? So we've got the D minus 1, we've got the 3D, but we've got to build up to it. So guys, where are electrons 1 and 2? 1s. So write it down, 1s. And I'm going to write down small enough that hopefully I can get this across the page. So guys, and again, we're just counting. Electrons 1 and 2, 1s. Where are electrons 3 and 4? 2. Electrons 3 and 4, 2s. Is that, you went quiet, so I'm scared. 2s, is that okay? So guys, 2s. Then where are electrons 5 through 10? 2p, is that okay? Just like Battleship, 2p. Now guys, where are electrons 11 and 12? 3s, Battleship, right? 3s. Then electrons 13 through 18, where are these dudes? 3p. Hey, I'm going to make this fit. Then, not quite yet, because we've got electrons 19 and 21st. Where are those? 4s. Yep, because of the overlap. Good. 4s. And then, guys, electrons up to 29 are in the D, but it's -1. So just like we said, this would be in the 3D. And there we go. So guys, step number 1, build up to the element that we're looking at. Then guys, step number 2, we need orbitals. Guys, let me show you a way to do this faster. All of the S's have 1. Some people find it's easier to just do all the S's at once. Then guys, how many do all the P's have? 3. They're dumbbell shaped, but we just draw boxes. When you do these in your homework, if you need to wrap around to another line, feel free to do that. Then guys, how many boxes for the D's? 5. But if you're not, say you're on the test and you're like, oh crap, I don't remember. Guys, all you got to know is they go up by odd numbers. So they go 1, 3, 5, and 7. But if you forget that, all you have to do is count. Guys, look at how many electrons are in the D. 2, 4, 6, 8, 10. So if there's 10 electrons in the D, you need 5 boxes to hold 10 electrons. Guys, however you get there, you need 5 boxes in the D. Yeah, well, you fill them all in from bottom. So guys, here we go. There's electron 1. Where does electron 2 go? Paired up. Then electron 3, 4 goes paired up. Now guys, let's do this again to make sure you're clear. 5 goes here. Where does 6 go? Next box over. 6 and 7. And then guys, we come back and we place 8, 9, and 10. Now guys, what if you lose count? Well, check this out. We just filled the 2p sublevel. Guys, the end of the 2p sublevel is electron number 10, so we know that we have 10 electrons on the board because we just filled the 2p, and then we can keep going. So this goes 11 and 12, then 13, 14, 15. Was that too fast? You okay with that? Then guys, 16, 17, and 18, then 19 and 20. But guys, remember, we're building up to 29. So now we need to go slow, and we go 21. Where does 22 go? Next box over. 22, 23, 24, 25, 26, 27, 28, 29. That's copper.
So the next one over is a space.
Yes, but let's talk about that. So guys, how do we know that this is right? Well, check this out. Look at where copper is. Copper is 1 box away from the end of the 3D. Copper is 1 box back, but copper has 1 empty space. That's how we error check. So guys, copper is 1 box back, and that would be the empty space. So Zach, to your point, if we added this last electron, now it would be the electron structure of zinc, and that's more stable than copper. But coming back to what we wanted to do, guys, this is the electron structure for copper. Questions? And it's also what makes copper so crazy conductive, right? When we wire our homes, we use copper, not zinc. frankly, zinc's cheaper. The reason we use copper is because that empty space there lets it conduct electricity like crazy. It's also why aluminum, it's also why aluminum's a really good conductor, because it's got one electron. So when we have odd electrons, either one or all but one, it makes things really good conductors. It's called the conduction band.
Is silver and gold conductors?
They are the best conductors. Yeah, like if you buy really, really high quality audio adapter cables, they're gold tipped. Yeah, gold is actually the most conductive element on the periodic table. Yeah, go ahead. Yeah, crazy, right? So guys, here's the deal. And understand I don't say this boastfully, but we need to say this. Guys, some of you are looking at these right now and you're going, hey, I get it. Josue's got 3 Ds right there. You know, guys, that's awesome. But guys, here's the problem. The only thing you can say with certainty right now is that you're good at watching me do these. And guys, I'm good at these. I have a degree in chemistry. This is what I do. So guys, what we need to do in the next 30 minutes is get you good at these. And so guys, that's what we're going to invest the rest of the day in. Grab your homework packets. And guys, we're on assignment number 2. Guys, flip it over to the back. Do the orbital filling diagrams. Are there, 7 or 8 of them back there? Do you mind if I look? 1, 2, 3, 4, 5, 6. So guys, do the orbital filling diagrams for those 7 elements. Please, guys, wrestle with these. Get frustrated. Succeed, fail, get help, whatever that looks like for you. But guys, you now have 30 minutes, which means you're not going to have homework because you can get these done. Guys, all the answers are on the wall. I would super love to sit down with you and help you with these. And guys, again, don't expect to be as good at these initially as I am. Please ask questions. It doesn't mean you're dumb. It means you're learning. Let me come and work with you. I'd really love to do that. So guys, the rest of the time is ours to invest in this. And guys, please invite me into the conversation.